National Electrical Code Section 110.14b addresses the requirements for making electrical connections. The first sentence states that conductors shall be spliced or joined with splicing devices identified for the use, or by brazing, welding, or soldering with a fusible metal alloy. The second sentence elaborates on soldering, stating that soldered splices shall first be spliced or joined so as to be mechanically and electrically secure without solder and then soldered. Interpreting these sentences requires careful attention to the meaning of mechanically secure. The code recognizes splicing devices as a primary means of achieving a mechanically and electrically sound connection. These devices, such as wire connectors or terminals, are designed and tested to provide a reliable and durable connection that can withstand mechanical stress, temperature variations, and electrical loads. The alternative methods, brazing, welding, or soldering, are also acceptable, but they come with specific requirements. The key requirement is that the splice must first be mechanically and electrically secure before the soldering process. This implies that the conductors must be joined in a way that provides inherent mechanical strength and electrical conductivity independent of the solder. The purpose of the solder is then to enhance the connection, providing additional conductivity, corrosion resistance, and mechanical stability. The question arises as to whether a simple twist and solder joint, without a separate splicing device, meets the requirement of being mechanically secure before soldering. The consensus among many electrical inspectors and engineers is that it does not. While a well-executed twist and solder joint may appear to be mechanically sound, it lacks the inherent reliability and durability of a connection made with a splicing device. Firstly, the mechanical strength of a twist and solder joint relies heavily on the quality of the twist and the thoroughness of the soldering. If the twist is not tight or the solder does not fully penetrate the joint, the connection can weaken over time, leading to potential failures. Secondly, twist and solder joints are more susceptible to corrosion, especially in damp or corrosive environments. The solder itself can corrode, and the dissimilar metals of the conductors and solder can create a galvanic reaction that accelerates corrosion. Thirdly, splicing devices are designed to maintain consistent pressure and contact between the conductors, even under varying temperatures and mechanical stress. Twist and solder joints, on the other hand, can loosen over time due to thermal expansion and contraction, or mechanical vibration. The code's emphasis on mechanically secure connections reflects the importance of ensuring long-term reliability and safety. Electrical connections are a critical part of any electrical system, and failures can lead to a variety of problems, including overheating, arcing, short circuits, and even fires. Therefore, the code requires that connections be made in a way that minimizes the risk of failure. Splicing devices offer a number of advantages over twist and solder joints in terms of mechanical security. 1. They provide a consistent and reliable connection that is less dependent on the skill of the installer. 2. They are designed to withstand mechanical stress and temperature variations. 3. They are less susceptible to corrosion. 4. They can be easily inspected and maintained. For these reasons, splicing devices are generally preferred over twist and solder joints in modern electrical installations. However, it is important to note that the code does allow for brazing, welding, or soldering as alternative methods, provided that the connection is first mechanically and electrically secure without solder. This means that if a twist and solder joint is used, it must be supplemented with some other means of providing mechanical support and electrical conductivity. For example, the conductors could be crimped together before soldering, or they could be wrapped with a conductive tape. Ultimately, the decision of whether a particular connection meets the requirements of the code is up to the electrical inspector. Inspectors are trained to evaluate electrical installations and determine whether they comply with the code's requirements. If an inspector is not satisfied that a twist and solder joint is mechanically secure, they can require that it be replaced with a splicing device or that it be supplemented with additional mechanical support. It is important to remember that the National Electrical Code is a minimum standard. It is not intended to be a comprehensive guide to electrical installation, but rather a set of rules designed to protect people and property from electrical hazards. Therefore, It is always a good idea to go beyond the minimum requirements of the code and use best practices to ensure the safety and reliability of electrical installations. In the specific scenario presented, where the inspector encountered twisted and soldered wires with wire nuts used only for grounding conductors, the inspector's initial assessment that the installation was not in accordance with the National Electrical Code seems reasonable. While the homeowner's work might appear neat and create a good electrical connection, it's the lack of a listed splicing device for the ungrounded and neutral conductors that raises concerns. The inspector's re-evaluation and consultation with other inspectors highlight the complexities of code interpretation. The differing opinions emphasize that code compliance can sometimes be subjective and dependent on local interpretations. However, the core principle remains that the connection must be mechanically and electrically secure before solder is applied. The use of wire nuts for grounding conductors is standard practice and generally compliant, as wire nuts are listed splicing devices. The issue lies with the twisted and soldered connections for the other conductors. To ensure compliance, the homeowner could consider replacing the twisted and soldered connections with listed splicing devices such as wire connectors or terminal blocks. These devices are designed to provide a reliable and secure connection that meets the requirements of the National Electrical Code. Alternatively, if the homeowner wishes to retain the soldered connections, they would need to demonstrate that the connections are mechanically and electrically secure without the solder. This might involve using a crimping tool to create a mechanical connection before soldering, or employing other methods to enhance the mechanical strength and electrical conductivity of the joint. The inspector has the final say on whether the connections meet the code requirements. It's always best to consult with the local electrical inspector before starting any electrical work to ensure compliance with local codes and regulations. Doing so can prevent costly rework and ensure the safety of the electrical installation. Furthermore, proper documentation and labeling of electrical connections are essential for future maintenance and troubleshooting. Clearly labeling each connection with its purpose and wire size can save time and effort when working on the electrical system. Regular inspections of electrical connections can help identify potential problems before they become serious hazards. Look for signs of overheating, corrosion, or loose connections. If any issues are found, they should be addressed promptly by a qualified electrician. By following these guidelines, homeowners can help ensure the safety and reliability of their electrical systems. Remember, electrical work can be dangerous, so it's always best to hire a qualified electrician to perform any work that you're not comfortable doing yourself. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with the National Electrical Code. They can also provide valuable advice on how to maintain your electrical system and prevent electrical hazards. The scenario illustrates the importance of understanding and adhering to the National Electrical Code when performing electrical work. While older methods like twisting and soldering wires may have been acceptable in the past, modern codes emphasize the use of listed splicing devices to ensure safety and reliability. Consulting with a qualified electrician and the local electrical inspector is crucial for ensuring compliance and preventing potential hazards. The discussion highlights several key points regarding electrical connections and National Electrical Code compliance. Firstly, mechanically secure means that the connection must have sufficient mechanical strength and integrity to withstand normal stresses and vibrations without loosening or failing. Secondly, electrically secure means that the connection must have low electrical resistance and provide a reliable path for current flow. Thirdly, listed splicing devices are designed and tested to meet specific standards for mechanical and electrical security and are therefore generally preferred by inspectors. Fourthly, alternative methods such as brazing, welding, or soldering are permitted, but they must meet the same standards for mechanical and electrical security. Fifthly, the electrical inspector has the final authority to determine whether a connection meets the requirements of the code. Sixthly, it is always best to consult with a qualified electrician and the local electrical inspector before starting any electrical work. And seventhly, proper documentation and labeling of electrical connections are essential for future maintenance and troubleshooting. In conclusion, while twisting and soldering wires may seem like a viable option, it is generally not considered compliant with modern electrical codes without additional measures to ensure mechanical and electrical security. Listed splicing devices are the preferred method for making electrical connections due to their reliability, durability, and ease of installation. Consulting with a qualified electrician and the local electrical inspector is essential for ensuring compliance and preventing potential hazards. Remember that the National Electrical Code is a minimum standard, and it is always a good idea to go beyond the minimum requirements of the code and use best practices to ensure the safety and reliability of electrical installations. Safety is paramount when working with electricity, and it's always best to err on the side of caution. If you're not comfortable performing electrical work yourself, hire a qualified electrician to do it for you. The peace of mind knowing that your electrical system is safe and compliant is well worth the investment. Moreover, understanding the reasoning behind code requirements, such as the emphasis on mechanically secure connections, helps to appreciate the importance of safety and quality in electrical work. It's not just about following rules, but about ensuring the long-term reliability and safety of electrical systems for yourself and others. The fact that one inspector approved the twisted and soldered connection while the other did not underscores the importance of local interpretations and the need to communicate with local authorities. Electrical codes are complex and can be subject to varying interpretations, so it's crucial to understand the specific requirements in your jurisdiction. This situation also highlights the value of continuing education for electrical inspectors and electricians. Staying up to date on the latest code changes and best practices is essential for ensuring that electrical work is performed safely and in accordance with the latest standards. The original inspector's diligence in rereading Section 110.14b demonstrates a commitment to accuracy and thoroughness. This is a commendable trait for any inspector and highlights the importance of continuous learning in the electrical field. The inspector's willingness to seek input from other inspectors also shows a collaborative approach to problem solving. By sharing knowledge and experiences, inspectors can ensure that they are making informed decisions and applying the code consistently. The ultimate goal of the National Electrical Code is to protect people and property from electrical hazards. By understanding and adhering to the code's requirements, electrical professionals can help to create safer and more reliable electrical systems for everyone. The scenario presented serves as a reminder that even experienced professionals can encounter situations where the code is not clear-cut. In such cases, it's important to rely on a combination of knowledge, experience, and communication to arrive at the best solution. And always remember that safety should be the top priority in any electrical installation. If there is any doubt about the safety or compliance of a connection, it's best to err on the side of caution and seek expert advice.